Any other homework? This is it? All right, here we go. Let's keep going. We were on this blending problem, correct? This is the last chance for me to find that piece of the puzzle that's not clicking for you. If you're still having troubles when you read a problem, not being able to figure out what the variables are, or not being able to figure out what the constraints are, or the objective function. This is the last chance, because we're going on to the next chapter from here. I stopped my allergy medicine, and I think I made a mistake. It's not cold enough yet for me to stop it. Okay. So I started back up last night, but it takes, anybody know full means? It takes like 3-4 days to finally get done, so you don't want to stop it. On this blending problem, I believe any of these problems, by the way, the key, I started thinking to myself, what is the piece of puzzle that's stopping people from getting what the variables are, what the constraints are? And I think the key is, you have to start using your imagination. When you're reading this, you've got to start visualizing in your mind the story. I'm the manager. I'm the one who has to make a decision on whether we're taking this contract for 1,260 lock sets of the knob and plate, of the lock and of the keys. And you've got to imagine what decisions, if this were real, what decisions you have to make. What is it that everyone's waiting for? Yeah, we're all waiting for how many we have to make of each one, and how many we're going to order from the subcontractor, because they're waiting, they're on hold right now, wanting to know how many they're making. So that's seems to be the way I come up with my variables. And when you read a problem like this, I know we got far enough for you, I think, to know the variables already. I can't remember, but you've got to imagine. I try to paint a picture where you are starting up this business on your own on the side, which is, I believe, the way entrepreneurs should start a business, to take away the risk of failing. Most businesses fail in the first year or two because they've taken on so much risk in the form of a loan in most cases, an overhead. And yeah, that space looks perfect. $10,000 a month, okay, without taking everything into consideration. If you just start out small and make sure that whatever it is your idea is, that it truly, truly is going to happen the way you think it could happen, by starting out small, then you take the leap and the risk. So the picture I tried to paint as I was describing this one is, you're in your garage, you're in your basement, and you have a pet, and you're saying, man, I'm spending all this money on dog food, and for half a pound's costing this much, I know I could do it better. I could probably make better quality dog food, or whatever the pet is, and I could probably sell it for cheaper and still make money off it. This would be a good little business. I say, whenever you find something that you can do better, we used to call it the mousetrap. The mousetrap. That's how we always reference it, because the old saying is, there's always a better mousetrap. That's the old saying. Meaning, a mousetrap has been around for years and years and years. The old-fashioned one, with wood, it's got a spring, you put cheese on it. That's how it used to always be. And everybody used it for years, and nobody ever improved on it. And yet that something that simple could easily be improved. There's mousetraps now that use sticky stuff, and the mouse starts to go for it, it sticks and can't get away. You can let it go free, alive, instead of killing it. There's all kinds of different mousetraps now. That's how it is with almost everything. Anything you're using in life, there's probably a better way to use it, or a better way to make it, or something like that. But if you jump, oh, this is such a great idea, I gotta borrow $1 million. You're setting yourself up for failure. That's it. You gotta test it out first. Start out small. Don't tell anybody about it. Because the moment you have a great idea, and it's really good, someone's gonna steal it. The point is, start this business small. In your basement, in your garage. Very little money involved. And in this case, I believe the story I was trying to tell you, so you could use your imagination a little bit, was that you went onto Craigslist and you found these little machines that will dump grain, whatever you set it at, perfectly into a bag, right? Does that sound familiar? Try to imagine that. But you have to set these things, they calibrate to exactly what you set it at. And you know you want 8 ounces, which is a half a pound. So each one, when you set them, have to add up. The 4 of them have to add up to 0.5 or 8 or however you write these constraints. We're going to write these in pounds. So when you set all those, they got to add up to 0.5, 50% of a pound. Got it? So just imagine what they're going to be. This may be like 1/10 of a pound. This one's maybe a little more than 1/10. This one's a little more than 1/10. And this one's a little less than 1/10. But they add up to 0.5. So by imagining, you can say, oh, I get where this is going. Your decision is how much of these 4 grain choices are we setting those at to dump into the bag? How much of each grain? And you're given this. And based on this information, you're using linear programming to find the perfect combination of 4 grains. And the answer is going to come to you as to what you set each one of those 4 machines that you put the grain in that's going to dump just a little bit as the bag goes by. All right? You ready? The constraint when it comes to the minimum requirements that the government makes for vitamin C, 6 units. This is a requirement. We must meet the government's requirements for this pet food in vitamin C. Less than equal, greater than equal, or equal? Greater than equal. We cannot go below 6 units. Then you're going to say, I need to represent all of my variables, which there are 4, because these are your choices. How much, the question is that you're trying to find the answer to is, how much of each of these grains should I put into each bag to make sure I'm meeting these requirements? The overall objective, if you were really doing this, you're saying, I'm making sure these requirements are met or even better by using the greater than equal. But your overall objective is to do what with this whole calculation? To minimize the cost. Because you know your target price, because you buy this pet food all the time, this is what gave you the inspiration. And you went into this going, I want to sell mine for less. I want to beat this competitor and with better quality. So maybe these numbers are even better than what the government's requiring. So your objective function is to minimize each variable, but turn the variables into cost by multiplying them by their cost per unit. 75 cents, 90 cents, 80 cents, 70 cents. That's how these are done. You have an in-class assignment at the end of today that we got to get to. And to me, it seems really easy. But I need to make sure you all can read a problem and write the variables, the objective function, and the constraint. We got to get to that point today. So I got to make sure you can do this in-class assignment on your own, no help with people around you. When we get to that point, and when you come up here and show me, if you got it mostly done and it looks like a 9 or above, that's fine. You can leave. But if not, I'm going to encourage you to keep working on it, because you really shouldn't be leaving the room unless you can do the easy one I'm about to show you, which is far easier than the 3 I hope we get time to go through. All right? All this today is, we're reading these problems, and our goal is picking out the variables and figuring out what the objective function and constraints are. And this first one, our constraints are these limitations the government put on us that we have to meet, at least have this much vitamin C, iron, and protein. The next one says 5 units of protein. Less than equal, greater than equal, 5. Greater than equal, we got to turn each variable, x1, x2, x3, x4, into representing protein. I go right to the protein column, and I go 12 times x1 plus 10 times x2 plus 10 times x3 plus 8 times x4 greater than equal to 5, right? Everybody see that? The next one was iron 5 units greater than equal again, because that's a government regulation. And I go right to my iron column, 0x1, or just leave it off there, same as 0, 14x2 plus 15x3 plus 7x4 greater than equal to 5. The vitamin C, I think we skipped, but here it is, 9x1 plus 16x2 plus 8x3 plus 10x4 greater than equal to 6. Objective function, minimize 0.75x1 plus 0.90x2 plus 0.80x3 plus 0.70x4. Stop. No less than equal, no greater than equal, no equal. Was there anything else in the story? That was it, right? Oh, 8-ounce package. You ready? x1, x2, x3, x4 all added together represent how much is going to dump into each bag equals 0.5. All this is in pounds. What goes into the bag is equal to 0.5, a half a pound, 8 ounces. That's how it will automatically take all of your answers, your optimal solution, your objective function value, is all going to be based on that half a pound bag because of that one constraint. You didn't have to change any of these numbers. You don't have to convert anything. You just have to tell it how much is going into one bag. It will come back with how much of each of these go into that bag. Because when they add up, they equal 0.5, a half a pound. This is what your plan is to market half-pound bag. Here's our objective function, x1, x2, x3, x4 times their prices. There's our half a pound bag right there, equal. There's each one of them. Here is what's that, vitamin C? Vitamin C. Here's the protein. Here's the iron. Yes, we know our variables are positive. We don't need to write that out. All semester we knew that. My question is, that third grain, the third grain, I'm setting that machine right now. What am I setting it at? Point what? Point. The third grain machine is represented by the x3. And it's telling you to set that to less than 1/10 of a pound to dump into that bag. This thing though you bought, this is the only money you spent so far, plus the generic bags you haven't even gotten printed yet. Which you haven't even designed your logo, nothing. You're right now you're testing this out. But it's telling you, you set that third one to 0.088. You set that second one to 0.213. And so on, and so on. And if you add these up, you'll see they're exactly, when that bag gets past all four of them, if you set up a true assembly line and somehow you're able to get something to make it move where you don't even have to be involved, and it's working right, there'll be exactly a half a pound in each bag. Now it needs to be sealed. And when you get a whole bunch of them, you randomly select a minimum of 30 business stats, all of you went through it, and you double check those, because if those 30 are all right around a half a pound, right the way it's supposed to be, you can assume all of that whole container is a half a pound each. Get it? That's what the stats was all about, getting you to that point, to statistically process quality control of your own business when you're starting out. Because that has to be done once you get big time. That's a must. And 30 of those are being brought out. And then we stop the machines, we're doing something else with them, we set them up to do it again, we're making a whole bunch. That batch now needs to be checked. 30 randomly selected, and everything checked on them that the exact amounts we wanted are going in. And if that all checks out, you can assume the whole thing is. And when you go to deliver that to Walmart, and you are so blessed to have gotten that order, it's the biggest order you've ever gotten. When you get to their distribution center, where they're splitting it up to send it in different directions, they're pulling 30 out, and they're checking it, and they're not sending you a check, and they're not letting you leave. You may have to put those back on the truck. They're not letting your truck leave until they've checked out 30 of those, so that they can have confidence that that whole giant container that you made are all going to be exactly as they ordered. All right, just get you ready for one. Here we go. Financial. Finance majors, are you ready? Look at this. How many? Well, let's jump right here. Right here. How many variables do we have? Wait, is this it? No, this is media. Where is the I passed it? Hang on, hang on. We're jumping right to how many variables? Look at. Now, I'm starting here because this will make a lot more sense if you understand each of the variables involved. You ready? This is your first job out of college at a finance brokerage company. This is a specialty finance brokerage company that works with investors who want to make some weird investments, let's say, where they have special rules involved. We need it to be this much in this and this much in this. So you meet with the client. You're being told, we're starting out with, I think it's $20 million. We'll look at it in a minute. We're starting out with 20, whatever the amount is. And the request from the client is that you decide how to invest it, but you only have 3 choices. However you want to invest it, and each month, you are assigned to this for 4 months. And each one of those 4 months, you have to decide every month how the money's invested if it's maturing from one of these 3 investments that you've already invested in the previous month, or the previous month before that. For example, this is the liquid account. And this is a 30-day investment. And at the end of the month, whatever it matures to, the amount you put in plus the interest on top of it, you have to decide what's happening to it the following month. And it can be any of these three because it matured. And all three of these are available every month. If you decide to put it in this investment, the construction loan, I don't want to get these mixed up. One of these are 2 months and one of these are 3 months. I better look. Because the point I'm trying to make, construction loans are 3 months. If you put in this construction loan, you say, if your optimal solution is to, in month 1, I'm putting $1 million of it in this construction loan. You got to say to yourself, okay, that money I don't have to make a decision on in month 2 because it's a 3-month investment, a commitment. Now we're at the beginning of month 3, that money's still there. I don't have to worry about that money. There's no decision to be made. At the end of every month, at the beginning of the next month, I guess, you have to decide how much money's maturing and what the new decision will be on it. Does that make sense? That's why there's so many variables, because every decision's a different variable, even though it's the same thing. You've got construction loan, construction loan, construction loan, but you have a construction loan opportunity every month. If there's some money maturing, let's say this money matures at the end of month 1, you could still switch it over to a construction loan, even if you put a construction loan money in there already in the previous month. There are some restrictions where you can only have so much in each investment total, and there's some restrictions that at the end, whatever's maturing after the 4-month period, some may not be maturing, but some are, you need, the client is asking you to have at least $10 million maturing at the end of the 4th month, because they have to move that $10 million to another investment they're going in on a high-rise building. Okay, so everybody understand the story. Let me say it again. You're working at the brokerage. The client's asking you to make decisions for 4 months on how to invest this money. This one's a 30-day investment. This one's 3 months. This one's 2 months. So if you commit to this, you're there for 2 months. So G1 is if you put money in there the first month. G2 is if you put money in there the second month. G3 is the third, and during the 4th month you may put money in there. Now, if it's the 4th month and you put money in there, it's got to be money that doesn't need to mature at the end of the 4th month to make that $10,000 commitment we have. The client has. Construction, you can put money in any month. The liquid account, you can put money in any month. How many variables? 12. 12 variables. G1, G2, G3, and they're all separate. They all stand for a decision that has to be made. That's where the confusion was on that the lot. You know, a lot of you were treating the set of keys being made and the set of keys being bought as one variable, but there are 2 different decisions. Even though they're both sets of keys, they're completely 2 different decisions. There's a decision to be made, how many are going to be made, and manufacturing is waiting for that decision. There's a decision of what's being bought, and the subcontractor has been waiting for that decision. Are you ready? You were given $20 million in your assignments to invest it for the next 4 months periods, and you've been told to maximize total interest earned. All right? Each variable's in there, and the amount of interest that would be earned from each variable is your objective function. So you have 12 variables in there with the amount each one could be earning. 4-month period, and here's one of the restrictions. The investor says they need $10 million at the beginning of the 5th month and at the end of the 4th month. So $10 million maturing, available for a high-rise building venture they're going into. Right now the objective function, max or min?
Max.
Max. I said it's each one, but you don't know what they're earning. I want to jump down here because this is crazy. If you go into a 30-day investment called the liquid account, it'd be like in real life going to a money market account. If you have money at Fidelity or one of those companies, and you want to get out of this mutual fund and transfer to a money market account, it's their version of a savings account. In this case, it's like a certificate deposit. It's there for 30 days. You're earning 3/4 of 1% for that 30-day period, which is unbelievable. That's all like 10% a year or something. I don't know what that is. It's crazy. So, in the objective function, how many L's did we have? L1, L2, L3, L4, all added together times the percent it could earn. What was it? This is going to be percentages. I can't remember if I want to do 0.75 or 0.0075. I cannot remember. I'm just going to put 0.75 right now. This one is 0.75. This one's 0.75, right? We'll see if this works or not. It could be 0.0075. Then it says at the top here, the government bonds that you could choose to go in, but that's a 2-month commitment. So I'm adding those in, plus G1, G2, G3, G4. I'm adding all those in, and it earns 2% over the 2-month period. So 2% for 2 months. But these represent the investment for 2 months and what you're putting in there. So it's earning 2%. Now this could be 0.02, just like that could be 0.0075. Just making sure you realize where this could be going. The last choice are these construction loans, 6%, but you made a 3-month commitment. So I've got to add those in. C1, C2, C3, C4. What was the percent? 6%? Wow. 6 plus 6 plus 6 plus 6. There's all 12 variables. There's the, I converted the statement, maximize the interest earned. There's the interest earned. The answer, the optimal solution is how much you're putting in each investment every single month. And when this multiplies the amount you put in times the percent, now I realize this should be 0.06, 0.06, 0.06. So I realize, because when this multiplies, it needs to know it's a percent. It's only 2%. And only, now this is tough, 0.0075. Plugging those little zeros in. Right? It's going to multiply the amount, every decision here, times its corresponding percentage. And at the end of the 4 months, when it adds this all together, it's trying to generate as much interest for your client as you can. All right, is that it? Is that the whole story? Maximize total interest. Have 10 million. Oh, to have 10 million. We got to have 10 million. Less than equal 10 million, greater than equal 10 million.
Greater than equal.
Because we have to have at least 10 million maturing. Greater than equal 10 million. I'm just writing 10M. We know that's million. We know this is money. So these variables have to represent the amount of money that would be maturing at the end of month 4. Let me go to all the variables here. Where are they all? You ready? These would be the variables maturing at the end of month 4. Start me out with some G's. How many months is a G investment? 2 months. So would G1 mature at the end of month 4? G2, G3, G3 plus, what about G4? G4 matures at the end of month 4?
No.
It goes into month 4, matures at the end of 5. That's out. Let's go to corporate now. So in G, there's only one of those that mature at the end of month 4, right? Let's go with corporate now. Corporate 1 is there for the first month, there for the second month, matures at the end of the 3rd month, so that one's out. C2 though, is there for the second month, 3rd month, matures at the end of the 4th month. I'm going with C2. C3 doesn't mature at the end of the 5th month. C4 doesn't mature at the end of 6 months. That's out. Liquid account, which one? L?
4.
I heard a 3 and I heard 4s.
4.
4. It goes in at the beginning of month 4, matures at the end of month 4. So this is L4. G3 plus C2 plus L4 has got to be greater than equal to. Now hang on a minute. Wait a minute. Does this represent how much it will be when it matures? Or does this represent how much we're putting into it? Putting in. We're not done. How much is this going to be when it matures? It's the amount put in plus what?
0.0075.
Plus interest. How much interest is it going to earn? Just a little less than 1%, right? So we have to make sure the interest is included. Are you ready? This number right here is 1.0075. I'm placing it right there. Help me with the corporate one. When that matures, this represents how much we put into it. But the amount when it matures will be itself 1 point, what's the rest of this? 0.06. 1.06. When I multiply the amount we put in times 1, it's itself, the 0.06 means add the interest. This calculation will turn it into the amount plus the interest. Help me with this one then. 1 point what on this G? 0.2. Now this is the constraint to make sure we have 10 million when each of those mature. I want to make sure I did that right. Just jumped down. It's been a few years. Where is that one? There it is. Itself plus the interest on each of these got to be greater than equal 10 million. All right? What was the other thing? I see a lot of other things there. Is there more to this? Oh, what about this? Right here. The company, the savings company, determine how to invest this over the 4 months, but at no time does it wish to have more than $8 million in either government bonds or construction loans. At no time, let me read that again, can it have more than $8 million. Okay, let me think about this. At the end of month 1, if we had put some money into government, it would not be maturing at the end of month 1, correct? So if we decide to put more money into it at the beginning of month 2, the amount we'd have in there total would be the amount we decide to put in month 1 plus the amount 2, because month 1 did not mature. Everyone agree with that? What happens when we get to the following month? Is the money from month 1 still growing? It matured. So that one would be out. But the amount we put in month 2, it continues on, plus the amount we put in month 3, because month 2 hasn't matured. So as I'm imagining this, I'm saying whatever we put in month 1, plus whatever we put in month 2, cannot be more than, I forgot, 8 million? 8 million. Now I want to do the next one. G1 matures, G2 still has money in it, and we're putting more in, which is G3 cannot go over 8 million. I've still got more to go, right? The next month, G2 matures, but G3 plus whatever we decide to put in the 4th month has to be less than equal to 8 million. That's how I imagine it. It covers all possibilities. The first month, there's no reason to write this, is it? I guess in the first month, it would be G1 has to be less than 8 million. I don't know if we need that one. I guess I got to check. Like I said, it's been almost a year. Where is the 8 million? Where is it? We do have to do. In the first month, the amount we put in cannot be more than 8 million. In the second month, the amount we had put in month 1 plus the additional amount we might put in can't be over 8 million. The third month. You get this? Because now we're going to do the construction one. Think about how long it takes to mature. Tell me it's not there. Good. You ready? I still got 8 million, 8 million, 8 million. Let's do the first one. In month 1, we're only putting money, if we put in money in construction loan, there's only the first one variable that we can do it in, which is C1 has to be less than equal to 8 million. Now let's go to the second one. C1, is there still money there carrying over? Because it doesn't mature, right? Plus, we could be putting money in the second month. Stop. Less than equal to 8 million. Let's go to the third month. Is it still there? It doesn't mature for 3 months, is that true? So now the third month, we've got C1 plus C2, because if that didn't mature, there's no way C2 matured. Plus, we could be putting more in, C3, less than equal to 8 million. And now we have one more month, is C1 in this last month. It's out because it matured, right? So we have C2, because that hasn't matured. Only C1 matured by the time we get to the 4th month. Plus C3, plus C4 less than equal to 8 million. And there it is. C1 in the first month, C1 and 2 in the second month, 1, 2, and 3. 1 matures, 2, 3, and 4. And that's 13 constraints. Go back up. What about how much money we have? Where's our money? However much we're investing in the first month, plus however much we're investing in the first month in the corporate, government corporate, and the liquidity account, it's got to equal 20 million. Because whatever doesn't go in here and here, this you can put pennies in this. I mean, the rest goes there. So this will add up to exactly 20 million. We're investing every penny of the investors in the investor point. Now, month 1 goes by. We have to decide what's maturing and what do we invest it in. However much we decide to invest in government bonds in month 2, plus however much we decide to put in corporate bonds in month 2, and the liquidity in month 2, has got to be equal to any of these that are maturing multiplied by themselves plus the interest. This says only that liquidity is maturing. That's not going to mature, and that's not going to mature, because that's 2 months and that's 3 months. Since this is the only thing maturing at the beginning of the second month, multiplied by itself plus the interest is the amount we have to make a decision on. And that's the only part we got to make a decision on. I got to get the variable to the left side. I subtract this much of L1 on both sides. So now I have G2 plus C2 plus L2 minus 1.0075 L1. All that's left on the right side is 0. Before I go to the next slide, don't look forward if you got a PowerPoint. Think about what's maturing now at the end of month 2, because we know we're going to have G3. We know it's G3 plus C3 plus L3 equals. Over here is everything that's maturing at the end of month 2. The liquidity account. 1.0075 liquidity number 2 will be maturing at the end of the second month. Is there anything else maturing at the end of the second month? Say it. I heard it. That's right, Justin. Say it. I can't.
Government bond.
Huh? The construction's 3 months long. We're at the end of month 2. So that's the, there it is. That money right there, it was there for the first month, but at the end of the second month, that's maturing. What's the interest rate on that we are going to get off of this G1? It's 1.02, 2%, so it's south plus 2%. So I'm adding to this 1 point, you said 02 G1. Liquidity number 2 is maturing. Government bond number 1 is maturing. And let's see, we got that one. That's not maturing, that's not maturing. And the only one left from here is that one. So there, now help me, I got to use algebra. I subtract that, move them over there, equals 0. With me? Everybody with me? Help me then at the end of month 3. Help me. First of all, what end of month 3, beginning of month 4. What's on the left side? G. Come on. Wait, are we recording? Because this is a darn good chance of participation. I need to know you guys are with me. All right. G1 the first month. G2 is in the second month. Here's the third month. What's the fourth month? G4 plus C4 plus L4 equals. What is maturing? Let's start with the liquidity account. What's maturing? 1.0075 L3 plus anything maturing else. C1. What percent are we getting off that one? 6?
Yeah.
6, C1. Anything else maturing? G2. Right? Because G1 finally matured here. Now G2, 1.02 G2. And I think that's all that's maturing. We got a C that's maturing, we got a G, and we got L. I don't know how there can be any more than that, right? You got it. Those, do you see, you got to imagine this. I mean, these are not, hey, we're only ordering from 2 suppliers, and there's an X and a Y. These are now multiple variables, multiple constraints. And you've got to imagine exactly how this would be done if you were doing it manually. So you can then take that logic and apply it to weighing these constraints. Here is month 3, I think. we said G1, or this is the beginning of month 3 is our decision. Here's G1 and L2 maturing. And then here is the beginning of month 4. We have 3 decisions to be made. Here is what's maturing. The construction, first one's finally maturing. The government, month 2, and month 3 is liquidity account. And then we subtract them, get to 0. The 10 million is on there. Here's the 8 million. Here's the 8 million for construction. And my question for you is, how much money out of the 20 million are we putting in the corporate bond in month 1? Your answer is, how much? The corporate bond, month 1, right away we're going, we love that 6%. How much are we putting in? Why only 8 million? You can only have 8 million in at all the construction investments at one time, and only 8 million in all. How much are we putting in the government bond in month 1? Because we were told we can only have up to 8 million. We're putting in the max. We want to get the most interest possible. We're putting the max in the construction loan. We're putting the max in the government loan. What does that tell you about month 2 on corporate, on the construction loan and the government bonds? Can you put any money in, yes or no? Because each of them are not maturing. Matter of fact, they're earning interest. Luckily, we don't get paid the interest until they mature. So we're not breaking the rule of going over the 8 million just because it's earning interest. The interest doesn't get added until they're maturing. We get the interest when we realize we have to reinvest it. How much interest for the 4-month period is the most you can get for this client? Even if there's an alternative optimal solution, you will not get more interest than this. How much? In 4 months, we're going to earn how much?
4.5.
How much?
4.5%.
No, how much money? 1 million. How much? 1,429,213 and we'll call it 80 cents in 4 months, and that's the most interest that could be earned with those restrictions and those requirements. Everybody get this? This was not easy. It's getting hard. No, seriously, I mean, you're supposed to be at this point now. Why are you guys laughing? Serious? Don't be wrong. 6, you have to form some constraints. You got to form some objective functions. But I'm going to show you some shortcuts that will make it much easier. But for these type of real world problems, there is no shortcut. You've got to start imagining this and say to yourself, if this were real, what is it I have to decide? Oh, out of this 20 million, what would be in each of these 3 investments? Okay, now we're on month 2. What do I have to decide? I got these 3 investments again. Well, how do I know how much money to invest? These previous ones are maturing. This is the way you set these up. You've got to imagine it. You've got to try to imagine this is your project, that you really have to do this. How are we doing at time? We got an in class. I want to show you one more. I'm going to go kind of fast, but don't worry. This one's hard. Don't write notes or anything. I just want you to see another one. Again, I'm going to present this to try to stimulate the imagination because I need you. It makes these so much easier if you can imagine this is really something that you have to figure out. This is really your project or your thing. Let's call this your company in this case because your specialty is to take wheels and we chrome them out? What do we do here? We custom wheels. And you got an order in for 1,000 standard wheels and 1,250 deluxe wheels for next month. And then another 800 standard and 1,500 deluxe for the following month. Everybody get that? You have something being made in 1 month, an additional being made in the following month. You got to fill this order. Everybody's waiting to find out what the process is that has to be made, what the decisions are in this concept. This is your orders. All the orders must be filled. The cost of making standard wheels, it costs you $10. Deluxe wheels, $16 if you can get these made during regular shifts, where everybody's on regular time. You realize you cannot get this order filled in time if you keep things on regular time, and you may have to go into overtime. But as soon as you schedule overtime, you've now taken your cost 50% higher. So tell me what the cost for a standard wheel would be. 15, and the deluxe? 24. You need those numbers. Because your objective, no matter if it's stated the way I want to state it, which is, your objective is to make as much profit off this deal as you possibly can. Another way of saying it is to, see it? I heard it? Keep your cost as low as possible. Depending on which information is given to you. Maybe it's given to you as the profit contribution, or maybe it's given to you as the cost. But your objective is to do one of those two on this project. We're doing it no matter what, but I need to know how many we're doing of what. The tough part about this one is, you have an open door policy to go ahead and make more than what's ordered in that first month. You go ahead, if you want to make more than 1,000 and more than 1,250, if you see there's a cost reason to go ahead and make more that first month, you just have to take into consideration there's a cost to put those into inventory waiting for the following month for 30 days. And that cost is $2. Every one of them that you make additional on top of the order that's been given, 1,000 and 1,250, is fine if it saves you money, but you got to take into consideration it's going to cost $2 for each one that is made over and above because it's being stored. This isn't easy, is it? But can you imagine? What is it you think that the question is that needs to be answered? What is everybody waiting for you to decide?
Minimum cost.
Say it again.
Minimum cost.
They are wanting the objective to be the minimum cost, but the ones that right now that are sitting in the production area, they're waiting to figure out how many something.
Standard wheels, deluxe.
How many what? I heard it. I heard you. You said
That was
it.
not me.
Who said it?
Standard wheels versus deluxe.
No, there's a female saying. Oh. Okay. They do want to know if they're getting overtime because that does excite them. But what'd you say?
Standard wheels versus deluxe wheels.
How many standard wheels should we be making right now? And when do we switch over and start making deluxe wheels? Because we need this time scheduled. And are we going into overtime? Because we need to start making phone calls next to plan our week out because we're not going to be able to pick up the kids from school if we're going into overtime. Because I don't want to miss the opportunity to make time and a half. Right? And everybody's waiting for this decision. But the deal is, you're not just deciding how many standard wheels we're going to make, how many deluxe wheels we're going to make. You have to decide how many standard wheels we're going to make during regular time and how many standard wheels we're going to make during overtime. How many deluxe wheels we're going to make during regular time this month and how many deluxe wheels in overtime this month. And then, next month, we need to know how many standard wheels to make during regular time and how many standard wheels to make in overtime and how many deluxe wheels to make in regular time and how many deluxe wheels to make in overtime. How many decisions do you have? I lost count.
8.
Was it 8? Is it 4? How many? 4 and 4?
Yeah.
8? Let's take a look because I cannot remember. There's 8. Standard wheels regular time for the month. Deluxe wheels regular time. How many are we going to make in overtime? This number, they can't wait to hear. Deluxe wheels overtime. We want to know. And we want to know if it's happening 2 months in a row. These are the decisions, and that's how you come up with the variables. Now, let's go to the objective function on the cost. Casey, was it you, Henry? I don't remember. You said the lowest cost possible. We got to turn every one of these variables into their cost. So let's go back here. Min or max? Min, how are we doing in time? 3 more minutes. Okay? Min, every variable has to be turned into cost. If I'm using SR, month 1, standard wheels, regular time, month 1, what number goes with it to turn it into cost? That's right. Because right here in this paragraph it said, every standard wheel you make during regular time is going to cost you $10. And then you do this with each variable. Plus SO1, standard wheels during overtime. Give me the number. 15. Dot, 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 dot. If you go, yeah, right here. Say it again. 16, right here.
24.
Right here. Trying to trick you, come on.
16.
No.
15.
15, thank you, I did trick you. Here.
24.
24, look at your variables, very good. Each one of these get their number as to the cost, whether it's being made during standard or regular time or overtime. Standard wheels, regular time, standard wheel, regular time is $10. 50% higher, overtime standard wheel, overtime is $15. Here's deluxe, 16 regular time, 24 overtime. There's your objective function. Now, hang on a minute, there's We need to fill this order, and we got an order in for 1,000 standard wheels in the first month. Greater than equal or less than equal?
Greater than equal.
You got outvoted. Greater than equal, because we need to make at least 1,000 to make sure the order's filled. We can make more than that, but the extra ones are going to have to go in inventory and cost us how much? $2. That's right. That is what makes this so hard, because the hardest part of that is trying to figure out how do you account for that $2 if you do make extra. And the way to do it, and this is what makes this so hard, is that you have to stare at it, and you go, it's a whole separate variable. It's a variable within itself. It will be a number of the amount that we made above the 1,000, and it has a variable, and it needs to be multiplied by 2. And it looks like this. Again, where am I? Wait, where's the cost? Standard wheels that went into inventory, deluxe wheels that went into inventory, and that adds 2 more variables as well. And then this will go on, and we could keep going, but we're gonna get to this because you guys have to come up with the variables. You have to write out what the variables are and define them. You have to write your objective function. You gotta write your constraint. I'm gonna read it out loud. I may even give hints along the way. If you haven't added it in within 10 minutes, within 8 minutes, then I'm going to give some additional hints for those that are still here to try to get you to finish it. And then whoever is still here, help each other get this